Welcome to the IFE table example 1 tutorial. This tutorial is meant to show you how to use an IFE table in conjunction with a word problem. An IFE table is a mathematical tool we can use with the word problem provided to figure out an unknown value about a gas. IFE stands for initial, final, effect, and as you can see, the four variables that we know are listed at the top. They are volume, number of particles, temp, and pressure. Similarly to our lab, two of these variables will be held constant and will be eliminated from our calculations. Something I want to highlight is the equation here. Final equals initial times the ratio, which we'll need to use to solve this problem. Let's go ahead and read the problem. A sealed balloon has a volume of 150 milliliters in a room at 25 degrees C. If the balloon has a pressure of 750 millimeters mercury, what would be the new pressure if the balloon expands to 500 milliliters at the same temperature? So notice that what we're looking for is a new pressure. What I'm going to go ahead and do is put a question mark into the final value of pressure, and if I kind of backtrack, they tell me my initial pressure was 750 millimeters of mercury. Let's go see what else we can find. They said the initial volume of the balloon is 150 milliliters. That'll be input into this box. And they said the room is 25 degrees C. Next, it says that the balloon expands to 500 milliliters. And they also tell me that the room remains the same temperature. Number of particles is not even mentioned, so what I get to do is go ahead and cross out this column. I notice that temperature does not change, so I'm going to go ahead and cross out that column. Those are my two constants that I will not use. Now what I will use is my highlighter to go ahead and show you what pieces we will be inputting into our equation. So here in green it says final. And my final value is listed here. That is what I'm solving for. My initial value is in magenta, so let's go ahead, let's label that. That is here. And then my ratio values are the only ones that are left, and they are over here to the left. Something that you have to realize is that there's two ratios you can choose. One of the ratios I can make is 150 over 500. The other ratio I can make is the reciprocal 500 divided by 150. At this point, you are probably asking yourself, well, which one do I use? This is where the effect row comes in. What I have to do is remember my relationships from the previous labs and try to fill out some arrows at the bottom to help me with this choice. I see that the volume increases from 150 to 500, so I'm going to put in an upward arrow here. And I know that when numbers of particles and temp is held constant, if the volume increases, the pressure should decrease. Therefore, I know the number that I have to choose is the ratio that will make 750 millimeters of mercury a smaller number. And that is going to be this ratio right here. Let's go ahead and write our final equation here. Final equals 750 times 150 over 500. That means that my final pressure will equal 225 millimeters of mercury. Once again, from my previous laboratory knowledge, I should at this point know that when volume increases, pressure will decrease if the numbers of particles and temperature are held constant. The last thing you will have to do for an IFE problem is to particle draw the scenario. So what you'll want to do is write before and after. and set up a particle drawing. In this problem, the volume goes from small initially to large finally. The number of particles were held constant, so I will mark n equals 3 for each box. And let's go ahead, let's draw on those particles. Here's 1, 2, and 3. There's 1, there's 2, there's 3. After looking at my IFE table again, I can tell that the temperature remains constant, so I will assign 1 whooshie apiece to both of these. But I do know that the pressure goes from high to low, so I'm going to go ahead and draw that respectively. And let's go ahead and put the whooshies down. So 3 pressure vents at 1 whooshie apiece. There should be 1 pressure vent in this box at 1 whooshie. And at this point, we have completed our IFE table and drawing.